Modern cars are heavily engineered to isolate us from the road. Between electric power steering, noise cancellation, and automated shifting, you can glide through a city street and feel like acceleration and turning requires zero physical effort. That illusion breaks the moment you drop a 1,500-kilogram trailer onto the back. You have instantly altered the vehicle's center of gravity and introduced a massive block of independent momentum into the equation. The consequences go straight to the fuel tank. Dragging that much mass using standard aggressive driving habits forces the engine to burn through excess fuel and spikes your emissions output. If you try to haul a multi-ton load using the same mental autopilot you use for a grocery run, you invite mechanical failure and terrible energy inefficiency. Managing that kind of weight requires active foresight. Once your combined mass exceeds 3,500 kilograms, a standard Class B license is no longer legally sufficient, requiring an upgrade to a B96 or BE license to handle the weight. Looking at this connection, the coupling claw must safely encompass the ball-shaped head, forming the primary bridge for kinetic energy. Notice the breakaway cable illustrated here. If that joint fails, this cable pulls tight and triggers an emergency brake inside the trailer. Most of these trailers also use an automatic loading brake. Because the trailer lacks its own brake pedal, its forward momentum against the slowing tow car pushes a sliding device forward, mechanically activating the trailer's own brakes. A hitch is a highly complex legal and mechanical system designed to safely distribute devastating amounts of kinetic force between two entirely separate moving bodies. When you turn right, the trailer wheels will always roll in a narrower curve radius than your car. To avoid pulling the trailer over the inside curb, you must actively swing the towing vehicle out to the left first to create the necessary space. Speed amplifies every geometric error. If you drive too fast, aerodynamic drag and shifting momentum can cause the trailer to violently hop. Once that oscillation starts, it can easily force the entire combination to lose control and flip. External forces compound the danger. Unloaded trailers with high, tarpaulin-covered loads effectively act like giant sails, making them highly sensitive to crosswinds that can push you out of your lane. This diagram shows the counterintuitive geometry required when backing up. Because of the pivot point at the hitch, forcing the trailer to go right requires the driver to initially steer the towing vehicle to the left. Pulling a trailer means accepting a constantly shifting physical footprint. You manage a flexible equation of space and momentum, requiring you to calculate where the back of the vehicle will be 3 seconds from now. Add gravity to that mass, and the physics get extreme. On an 8% downhill slope, a 1,500-kilogram trailer exerts roughly 550 newtons of raw pushing force directly into the tow car's braking system. Relying on progressive braking, pressing softly at first and harder later, can easily overheat the brake pads to the point of complete failure. Instead, use degressive braking. Apply strong pressure early to establish control, then ease off gradually. The most effective way to manage that hill is the engine brake. By shifting into a lower gear, you force the engine's internal compression to absorb the trailer's kinetic energy, slowing you down without touching the brake pedal at all. This tachometer illustrates how those exact same energy principles apply to everyday eco-driving. Shifting up early keeps the engine in a low rev range, utilizing the overrun fuel cutoff to let the car roll in traffic with almost zero fuel consumption. Looking at this vehicle, you can see unnecessary roof ballast. Removing items like empty bicycle racks immediately eliminates aerodynamic drag. Taking off just 10 kilograms of weight and maintaining proper tire pressure saves a significant amount of fuel over time. Whether you are trying to prevent brake fade on a steep mountain pass or cut your daily urban fuel consumption by 30%, the solution is identical. You have to work in harmony with the vehicle's kinetic energy. Managing that energy output scales all the way up to macro-environmental regulations. These street signs designate strict environmental zones, restricting access only to vehicles with specific emission stickers to control fine particulate matter in the air. Here we see the regulatory systems applied to commercial transport. Devices like tachographs physically log activity to ensure drivers do not exceed 9-hour daily limits, enforcing rest to prevent catastrophic fatigue on the road. Notice the orange warning board on this truck. Advanced driving requires reading these external codes to identify when surrounding vehicles are carrying dangerous goods or requiring extra width on narrow roads. True mastery of the road requires you to switch off the mental autopilot. By understanding the raw physics pushing your vehicle and respecting the regulatory systems designed to keep the road safe, you actively protect your engine, the environment, and human life.